It's high noon at the OK Corral. Our lone sheriff stands protector of all the broccoli in the land. To his right, irrigation. One-time friend made foe. To his left, mulches. Another friend made foe. With our hero backed into a corner, how will he bring these two troublemakers under control?
Troubleshooting small-scale broccoli production. The purpose of this video is to provide small-scale broccoli producers with strategies for troubleshooting problems regarding irrigation and mulches. The information presented in this video was collected from a 10-week broccoli production operation. This video addresses the two problem areas of irrigation and mulches, as well as providing suggested response techniques. Problem 1. Irrigation. Irrigation is the artificial application of water to the soil. Here is a description of our drip irrigation setup.
We have 10 lines that are each 10 meters long, and then the subline is also 10 meters. The water comes from this 35-gallon bucket over here.
There are many problems you may face with drip irrigation. The first problem is underwatering. To determine if you are adequately irrigating your crop, it is necessary to monitor soil water availability. We used 6 watermark sensors to monitor the tension that soil particles hold onto water in units of centibars of pressure. Higher centibar readings mean the soil is holding onto water more tightly, and therefore less water is available for plant uptake. Our sensors were interspersed throughout the plot, with 2 placed in each mulch type. A graph of the data reveals periods of wetting and drying, and irrigation can be timed to keep soil water tension in an acceptable range for both the soil and crop type. This graph shows tension readings after we transplanted our broccoli, with values consistently above 40 centibars. For silt-loam soils, readings above 20 centibars implies the need to irrigate, and a range of 40 to 60 centibars indicates that over half of the available water is gone. Clearly, we did not irrigate enough. This graph shows values from when we began additional irrigation. Most of the readings are within the acceptable range for crop growth, with values below 40 centibars. Another irrigation management problem broccoli producers can face is the occurrence of transplant shock. Transplant shock is environmental stress after transplanting, which causes wilting, leaf drop, or chlorosis in plants. Our plot experienced a massive die-off of plants in the few days following planting. Many of these plants died from the initial transplant shock due to very dry soil and high temperatures. Recovering from insufficient irrigation. One way to aid in recovering from insufficient irrigation is to create a water budget table, which is a tool for scheduling irrigation. A water budget table reveals how much water is available for plant uptake each day by monitoring the amount of water added to the system through rain or irrigation, the amount lost through evapotranspiration each day, and the amount held by the soil that cannot be absorbed by roots. When the amount of water lost through evapotranspiration exceeds the maximum allowable depletion, it is time to irrigate once again. After taking these measurements, we confirmed that our need for additional water and applied an extra 32 gallons of water per day for 2 weeks. We also used sprinkler or spray irrigation on the days when the temperature was the highest to avoid further losses. Although these methods helped us recover from insufficient irrigation, these are good techniques to implement before planting or irrigating to prevent crop loss.
Problem Area 2, mulches. In our plot of 10 by 10 meters, there are 10 rows of broccoli. Within those 10 rows, we have 3 mulch treatments: straw mulch, plastic reflective mulch, and bare soil. Mulch is a good thing. It regulates soil temperature. Mulch helps to keep soil temperature more constant by acting as an insulator. From the data, we observe that soil under plastic mulch tends to be 3 to 5 degrees higher than soil under straw mulch. Soil temperature of the 4 rows of bare soil are much more variable. Mulch helps foster soil aggregation. More aggregates means improved soil structure. Compared to the control rows, the straw and plastic mulched rows contained more soil aggregates. The plastic mulch rows contained the most. Mulches increase plant size. By examining the trend lines of this graph, we see that the plants in each row began with similar biomasses. Within the first month, all of the biomasses are similar, yet in the second month, the biomasses of the mulch rows increased rapidly. There are many potential problems you can face with mulches. Wind is one of them when using plastic mulch. Wind can cause the plastic to be blown over, therefore covering the plants. This causes a reduction in sunlight capture and possible physical damage. Sufficient soil should be added to the edges of the plastic mulch to ensure that it stays pinned to the ground. Pests are another problem. When using straw mulches especially, there is a potential for tunneling pests such as rabbits or moles to infiltrate the soil. Furthermore, straw mulches can lead to molds and viruses growing on plants and roots during the rainy season. Remember, in the wild, wild west, there can be some wild, wild pests. Remedies. Choose the right mulch for your production system. Properly apply an ample amount of mulch. Troubleshooting small-scale broccoli production should be considered case by case. Hopefully the information in this video is insightful and beneficial, enabling you to make a more well-informed decision on responding to challenges you face in your own broccoli production.
With the problems under control, our hero walks away into the sunset, knowing that he and his broccoli, with a little help, can live to see another day.